Number 32, last part, part 3, we're going to try to find the transformations that will map the figure on the left to the figure on the right. Okay, assuming they are congruent, let's assume that for a minute, because otherwise we can't guarantee it off the graph. Okay, so assume for a minute triangle EDC is congruent to triangle ABC. Let's assume for a minute that they are. Then we could, and I checked orientation and everything, so we could rotate triangle EDC centered at C by an angle that maps E prime to A. Now, why do I say it that way? Most of us will probably agree it looks like 90 degrees, but we cannot ever trust what it looks like off the graph. The reason we were able to really know that these were going to map was on the graph, we can actually measure the side lengths. And the side lengths and angle measures, they're all going to match. So we know that these figures are in fact congruent. However, we're not sure on this. There's no way to measure, but we're just going to assume for a minute that they are. And if they are, that's what's going to work. Again, would your teacher accept 90 degrees? Probably, especially if that is a right angle. Then we know it's going to work. Okay? So I just leave the angle to this because I should. Which of the diagrams has an invariant point? The only one that I see, yeah, a point that doesn't move is figure 3. And of course, explain means use your words. Okay, point C is in the same location for both the image and the pre-image. Okay, that's what invariant point means. Invariant points don't move. Okay, which of the diagrams preserves orientation? The first one and the third one. Okay, explain the arrangement of the vertices is the same for the pre-image and the image. Okay, what do I mean by that? For QRST, let's remember the arrangement of the letters was clockwise, and then likewise for its corresponding right here, X U V W, right? Or U V W X, sorry. So that's once those are the same arrangement, we're all set. Which of the diagrams is a rigid motion? All three are rigid motion transformations because they're congruent. Because, let's see, the transformations we used line reflection, translation, and rotation are all rigid motions. keep image congruent to pre-image is what it means. So none of them change size. Those are some of the things you got to say for rigid motion. Next, exterior angles theorem. So when we did problems in class, some of the problems didn't really require the use of the exterior angles theorem. For instance, if I had 110 here and a 58 there to find that angle, you could have used linear pair to put 70 there, then add what you have, and of course subtract from 180. So those were some of the problems we did with exterior angles theorem. But once you take away the numerical ones, once we throw algebra in, we actually have to know the exterior angles theorem, which says the two remote interior angles, their measures have a sum that's equal to the exterior angle. So what we're going to do is 2x plus 3, that's an interior angle, plus 51 should end up being the same as the other angle's outside angle. So 4x plus 8. Now combine like terms. I'll subtract 2x. That's how, just continuing the algebra. X is 23, but we want the measure of the exterior angle. So let's leave a little bit of room, hopefully. Now we have to plug in. So 4x plus 8 is 4 times 23 plus 8. 92 plus 8 is 100. Let's make sure that yes, that does work. So the measure of the exterior angle is 100 degrees. See, we're good on time. So 34. Another area of a triangle. I don't believe, I'm going to take a look at the dimensions here. Don't believe we have a right angle, but we might. I'm just counting up the side lengths here. Okay, that's a slope of negative 1/3 this side. This is a slope of 3/2, negative 3/2, I should say. This is a slope of 2. None of them are negative reciprocals, so we don't have any right angles. So we're going to have to get the area of this triangle, I think we're going to have to box it in, is the best, most efficient way. So I'm going to take area of the box. Okay, so we're looking at 6 by 6. Okay, so 6 times 6 is 36. I'm going to call this triangle A, triangle B, triangle C. We're going to cut away the extra triangles. So the dimensions are 6 and 2, so the area is 6. For triangle B, we got 4 and 2, 4. And for triangle C, half times 6 times 4. All right, I usually add those together to get 22. So the area of the triangle is 36 minus the 22, which is 14. All right, so the area of that triangle ABC, I'm not sure which one's A, B, or C, so why don't we just throw some letters in there? Okay, so I'll put those in there since they were missing. 14, use coordinate geometry to show whether the triangle is isosceles or scalene. We need to figure out if any sides are congruent. On the coordinate plane, the way to do that for is side lengths. We need side lengths to find out if congruence happens. We should just calculate them all, show that either two of them are the same or all three are different. But let's try to start with AB first. We need distance formula or Pythagorean theorem. I'm going to use distance formula. Notice that I put these numbers on the diagram, so now I'm allowed to use them, and this is appropriate work shown. So I get 40. So AB has a length that's equal to square root of 40. You don't have to give me the decimal value. I would rather just see the square root of 40 on the diagram with its corresponding appropriate side. AC now we're going to work on. That's 6 and 4. 36 and 16, 52. All right. And what we have is now AC has the length of square root of 52. And then the last one, let's squeeze it in over here. So the last one is BC. I need 2 squared plus 4 squared. Let's see, that's 20. So now BC has the length of square root of 20. All right, they're all different. Right? Yes, all different. We should draw this conclusion now, of course. So we should talk about something in B. This is still B continued. Let me get rid of that then. We're continuing on with B. All lengths are different. So scalene. Show whether it's a right triangle. One way to go right now is to apply the Pythagorean theorem, but that's not really the chapter we're in. The chapter we're in would be more along the lines of slopes. So show that there's no right angle. So what we do with that is we talk about slopes of every side. AB's slope. It is going to be 6 over 2, but it's negative. Okay, we're moving down as we go left to right. That reduces to negative 3 over 1. BC, the slope is positive 4 over 2. That reduces to 2 over 1. AC uses slopes of, let's see, it looks like negative 6 over 4. All right, so what we talk about with these is none of these are negative reciprocals. Therefore, there are no perpendicular sides on triangle ABC. With no perpendicular sides, there is no right angle. So triangle ABC is not a right triangle. Okay, that's it for this video, and we've got 1 or 2 more left.